Ever wondered what it takes to turn the rain falling on your roof into safe, clean drinking water? Collecting rainwater is a great start, but making it truly usable for your home, farm, or factory is where the real magic happens. It's not just about catching the water, it's about making sure every single drop is pure and safe. Let's dive into the amazing technologies that make this possible. First things first, we need to get rid of the physical gunk. Imagine all the leaves, twigs, dust, and other bits that rain washes off your roof. The first line of defense is filtration. Simple mesh screens are great for blocking larger debris like leaves. Next, the water often sits in a sedimentation tank. Here, gravity does the work, allowing heavier particles like sand and silt to settle at the bottom. Finally, the water passes through multi-layer filters, which might contain sand, gravel, and other materials. These layers trap even finer suspended solids, leaving the water looking much clearer. This initial cleanup is super important because it prevents downstream equipment from getting clogged and damaged. Now that we've removed the visible impurities, it's time to tackle the invisible threats, microorganisms, and chemical contaminants. This is where more advanced purification methods come in. Ultraviolet or UV treatment is a game changer. UV light zaps harmful bacteria, viruses, and other pathogens, making them unable to reproduce. It's a chemical-free way to disinfect water. Another common method is chlorination. Adding a tiny, controlled amount of chlorine ensures the water stays microbially safe, even while it's stored in a tank. But what about strange tastes or smells? That's where activated carbon filters shine. They are fantastic at absorbing organic compounds, pesticides, and other chemicals that cause odors. Biosand filters also work wonders, using a natural biological layer to remove pathogens and impurities. These techniques together make rainwater safe enough for all sorts of household and industrial applications. The materials we use for filtration are just as critical as the methods. Think of it like choosing the right tool for the job. For microscopic pathogens, ceramic filters are incredibly effective. Their tiny pores physically block bacteria and protozoa. For even more advanced purification, we turn to membrane technologies, techniques like reverse osmosis or RO. Use a semi-permeable membrane to remove dissolved salts, heavy metals, and other pollutants at a molecular level. This is how you can turn almost any water source into ultra-pure water. And to make sure everything is working perfectly, modern systems use smart sensors. These sensors constantly monitor water quality in real time, checking things like turbidity and pH. If they detect a problem, they can automatically trigger the right treatment process. It's this combination of high-tech materials and smart monitoring that guarantees a consistently safe and reliable water supply. One of the best things about rainwater purification systems is that they're not one-size-fits-all. They are incredibly modular and scalable. For a single-family home, a compact all-in-one unit can be installed to serve daily needs. On a larger scale, entire communities can benefit from a centralized purification plant that treats rainwater collected from multiple buildings. And for industries that need huge volumes of water, like for manufacturing or large-scale irrigation, massive treatment setups can be designed to meet their specific demands. This flexibility means rainwater harvesting can be adapted for almost any setting, from dense urban centers to remote rural villages and sprawling industrial parks. To take efficiency and safety to the next level, we're now integrating purification systems with smart monitoring technology. Imagine a network of IoT sensors deployed throughout your rainwater system. These sensors continuously measure key water quality parameters like turbidity, pH levels, and the presence of specific contaminants. All this data is fed to a central dashboard, but it doesn't stop there. This smart system can use automated valves to adjust the treatment process on the fly. For instance, if a sensor detects a sudden spike in turbidity after a heavy storm, it can automatically increase the filtration intensity. Even better, artificial intelligence can analyze historical data to predict potential contamination events and optimize the purification cycles, saving energy and resources. This seamless integration of technology makes the entire system more reliable, reduces the need for manual oversight, and lowers long-term maintenance costs. This isn't just theory, it's happening all over the world. Let's look at a few success stories. In Singapore, a country with limited natural water sources, rainwater is collected on a massive scale and treated to meet stringent potable water standards, feeding directly into their national reservoirs. In Germany, many modern urban buildings are equipped with modular systems that use a combination of biosand and membrane filters to supply non-potable water for toilets and gardens. And in rural communities in India, simple low-cost filtration methods are being implemented to provide safe drinking water for thousands of families, drastically improving public health. These real-world examples prove just how adaptable and effective rainwater purification can be in diverse environments. So, what does the future hold for rainwater purification? It's all about a smarter, more integrated, and sustainable approach. We're moving towards fully automated systems where IoT-enabled sensors provide constant real-time quality control. Artificial intelligence will play an even bigger role, using predictive models to optimize purification schedules based on weather forecasts and water demand patterns. The ultimate goal is to seamlessly integrate these decentralized rainwater systems into larger urban water grids. This will create a more resilient water supply, providing a reliable backup during droughts or in case of a contamination event in the main system. These advanced systems are transforming rainwater from a simple alternative into a safe, dependable, and vital resource for all our needs. With today's incredible purification technologies, every drop of rain we harvest becomes a precious resource. It's no longer just water. It's a key to building sustainable communities, powering industries, and securing our water future. Thanks for watching, and don't forget to subscribe for more insights into the world of water.